In our last chat, we dove into how computers talk to each other across networks, all that cool stuff with protocols and packets. But that brings up a really big question. When you pull up a website or you open a file from a shared drive, that information doesn't just magically appear. It has to be stored somewhere, waiting for you to ask for it. And the answer to that question is the real hero of this story, the server. So, what exactly is a server? It's funny because we tend to think of it as this big, impressive piece of hardware, but really, it's all about the job it does. At its heart, a server is really just any computer, and I mean any computer, that's running special software. And that software's job is simple. It just sits there, listens for requests from other computers on the network, and then responds to them. You could actually turn your own laptop into a basic server if you wanted to, but there's a pretty big difference between what you could do and what a real business should do. Think about it this way. Your laptop is like your kitchen at home. It's great, it's perfect for making dinner for your family, but could you run a packed 200-seat restaurant out of it, 3 meals a day? No way. It would just fall apart. That's why organizations use special, purpose-built servers. They're the industrial-grade, stainless steel kitchens of the tech world, built to run 24/7 and handle thousands of orders without ever skipping a beat. And this whole setup creates this fundamental relationship that pretty much powers everything we do online. It's a really simple, elegant idea called the client-server relationship. Let's go back to our restaurant. You, the person sitting at the table ordering food, you are the client. You make a request to your waiter, the waiter acts as the server. They take your request, go to the kitchen, and then come back with the response, your meal. It works the exact same way online. Your computer is the client, and the machine holding the website you want is the server. Simple as that. So let's see this in action with a few colleagues. First up, Client A wants to see the Hello World page. Her computer sends a request out, the server gets it, finds the right file, and sends it right back. Perfect. Success. Now, at basically the exact same time, Client B asks for a totally different page, the example page. The server doesn't even blink. It juggles both requests, finds the page for Client B, and sends it over. Easy. But then Client C comes along and asks for the Annual Report 2019. The server looks for it, and it's not there. So what does it do? It sends back an honest response. Sorry, I couldn't find that. And that right there is the famous 404 page not found error we've all seen. A good server doesn't just give you data. It also tells you the truth when it can't find something. Now, from a risk management point of view, this is incredibly important. Think about it. If your personal laptop gets compromised, that's a really bad day for you. But if a central server gets compromised, that can be a catastrophic day for every single person who relies on it. And that's exactly why servers have to be protected with much, much stronger security controls. Okay, so a company doesn't just have one big server that does everything. That would be chaos. Instead, it's more like a digital back office with a bunch of different types of servers, each one with its own specialized job. Let's take a quick look at some of the most common ones. So you've got your file server, which is exactly what it sounds like. It holds all the important documents, contracts, reports. The risk there? Confidential data getting exposed. Then you have a mail server, a huge target because it holds all the sensitive email communications. A web server? Well, that's facing the public internet, so it's a major attack surface. And then the big one, the authentication server. This is where usernames and passwords live. This is quite literally the keys to the kingdom. If that gets compromised, it's game over. So for anyone working in governance, risk, or compliance, the lesson here is crystal clear. You cannot treat all servers the same. It's all about classifying the assets, the data, on each server, and then applying controls that are proportional to how sensitive that data is. The security you put on a public web server is going to be totally different from the virtual fortress you build around your authentication server. Okay, so we've got all these critical, purpose-built servers, but where do we actually put them? You can't just stick them in a spare office closet and hope for the best. That opens up a whole new world of problems. And this is exactly why data centers exist. I mean, really think about it. A server sitting in a regular room is just so vulnerable. A power outage could take it down. A broken air conditioner could cause it to overheat and fail. Someone could literally just walk in and unplug it. No business can afford to have its critical systems be that fragile. A data center is basically a fortress built for data. It's designed to solve all of those problems. You've got intense physical security, locks, badges, cameras. You've got redundant power, giant batteries and diesel generators in case the grid goes down. You have industrial-strength cooling systems to keep everything at the perfect temperature. And for the really important stuff, the data is often copied to another data center in a completely different city or state for disaster recovery. And for an auditor, this is a massive deal. Regulations like GDPR have really strict rules about not just how you protect data, but where that data can physically live. Auditors have to verify that sensitive data is kept in certified, secure environments, like a proper data center, not just some random dusty closet. So today, organizations have a really interesting choice. They can build their own data center, which we call on-premise, or they can rent space and computing power from a giant provider like Amazon, Microsoft, or Google. And that's what we call the cloud. But moving to the cloud brings up a super important question. Who's responsible for what? This brings us to a concept you absolutely have to know: the shared responsibility model. Think of it like this. The cloud provider, say Amazon, is responsible for the security of the cloud. That means the physical building, the hardware, the power, the cooling, but you, their customer, are responsible for security in the cloud. That's your data, your applications, and crucially, who you give access to and how you configure everything. And this is the most important takeaway of all. Moving to the cloud is not a way to outsource your responsibility. So many companies make the mistake of thinking the cloud provider is handling all the security. They're not. They're handling the security of the building. You still have to lock your own doors. The physical location of your server might change, but your fundamental duty to protect the data on it never, ever goes away. So we've gone on quite a journey. From a single computer acting as a server to a high-tech data center fortress, and now even to the cloud. We have a much better idea of where our data actually lives. But all of this just leads us to an even more important question. Whether your servers are in your building or in someone else's, do you really know who holds the keys?